You can screenshot this and refer back to it. But I'm going to actually go through this just so we can understand why the answers are what they are. So the first question, the digestion of carbohydrates is complete when they have been reduced to which form? When are proteins digested completely? So carbs, we said, including polysaccharides and disaccharides, must be broken down to monosaccharides, right? That's glucose or galactose, okay? As far as proteins, they must be broken down to peptides or amino acids to get into the cell, and then they must be amino acids to get across the basolateral surface. Question 2, are absorbed fats transported directly into the bloodstream? So fats are not absorbed into the bloodstream. They are not water soluble, so they cannot go directly into our arterial supply. It's actually going to clog our arteries. What they do is they're absorbed into the lacteals, right? So they're transported into the cell in their singular components. They're repackaged into triglycerides, then they're repackaged into chylomicrons, then they're transported into the lymphatic circulation via lacteals. Then they make their way to the liver, where they're sorted, et cetera, et cetera. Question 3, what role do bile salts play in the digestion of fats? Bile salts emulsify fats, so they break those big fat goblets into small lipid droplets so that the pancreatic lipase can then come and begin to break down digest those fats. So the process of emulsification is actually not digestion, right? That's just breaking them down. Digestion really implies an enzymatic process. And bile salts are not enzymes, they're just mechanically separating the fat. The actual process of digestion happens by lipase, where we have enzymes acting on those smaller droplets. Okay. All right, we skipped over another set here. Okay, and these also have responses, which is okay. So question 1, what is the role of carbonic anhydrase in stomach acid secretion? Which other ions are secreted along with hydrogen ions? So carbonic anhydrase, we said, is located inside these parietal cells, and it catalyzes the reaction which converts CO2 and water into acid and bicarbonate. So it first becomes carbonic acid, and then that carbonic acid dissociates into hydrogen ions and bicarb. And we said that the hydrogen ions move across the apical surface. They're exchanged for potassium via the proton pump. And then bicarb moves across the basolateral surface. It's exchanged for chloride. And then that chloride will then be passively moved across the apical surface and combine with those hydrogen ions to give us hydrochloric acid. And so these parietal cells will then secrete acid into the stomach via that mechanism. Question 2, of the following stimuli, which would be expected to stimulate gastric acid secretion? Distension of the stomach for sure. Distension of the duodenum, no, right? We're talking about acid, we're talking about what's happening in the stomach. Distension of the duodenum will actually block the distension, the acid secretion, block the acid motility via the hormones there, which are CCK and secretin, okay? Increased protein digestion products in the stomach, yes, that's going to be a stimulus for acid secretion. And then increased acidity in the duodenum, no, that's going to be the opposite, right? Increased acidity in the duodenum is going to stimulate secretin, and we know secretin inhibits acid secretion as well as inhibits gastric motility. And then the final option was increases osmolarity in the duodenum. This should be increased osmolarity. Increased osmolarity in the duodenum, again, is going to stimulate the secretin and CCK release, which will negate or block acid secretion. So the only stimuli here for acid secretion are distension of the stomach and increased protein digestion, and although it's not mentioned here, fat digestion as well, or fat products in the stomach. Okay, so fat and protein products, which include peptides, amino acids, and then distension of the stomach are the stimuli for gastric acid secretion as well as gastric motility. All right, question 3, of the following stimuli, which would be expected to stimulate the secretion of enzymes or bicarbonate-rich fluid by the pancreas? So enzymes or bicarbonate-rich secretions by the pancreas, we're really looking at what is going to increase secretin and CCK release. So increased acidity in the duodenum, yes, that's going to stimulate those two. A rise in plasma CCK, yes, that's going to stimulate those two. A rise in plasma secretin, yes. So the secretion of both of these hormones will have both of these effects, because remember, not only is CCK having its own function of bile secretion, but it's also potentiating secretin. And not only is secretin having its own function, bile secretion and bicarbonate fluid, but it's also potentiating CCK. So if we are activating secretin, we might as well be activating CCK because they're potentiating the secretion of each other. The third option here, decreased protein digestion products in the duodenum, that is going to be the opposite of a stimulus for enzyme and bicarbonate release. Okay, if we increase protein digestion in the duodenum, that would be a stimulus. And then the final one, increased fat in the duodenum, yes, that is going to be a stimulus for enzyme secretion to break down that fat and bicarbonate fluid to neutralize the acidity of those contents. Okay, so the stimuli here are going to be increased acidity in the duodenum, rise in either CCK or secretin levels, and increased fat in the duodenum, or proteins, although it's not mentioned here. All righty. Okay, so that brings us to the end of the GI system. And I'm really trying not to be in a haste here and rush into the reproductive system. I'm really trying to take our time, make sure that we're really understanding the key concepts here, because it's going to make your studying a little bit easier to kind of go over this. It's going to make a lot more sense. So let's wrap up by looking at a few clicker questions or practice MCQ questions. And as usual, I'll display the question here. And I'll give you an opportunity to kind of think about it, choose an option, and then we'll discuss the answer. Okay, so here's question one. I'll give 30 seconds and then we'll go over the answer. Okay, so let's go over the answer here. Which layer of the wall of the GI tract contains the nervous fibers that form the enteric nervous system? So we've got the mucosa, the submucosa, the serosa, and the muscularis externa. And we said the submucosa has the layers of the enteric nervous system, which is the submucosal plexus. Okay. Now, I don't like this question because the muscularis externa also has the myenteric plexus. So this is probably not an ideal question because D could also be a correct answer. Both the submucosal plexus and the myenteric plexus are a part of the enteric nervous system. All right, let's keep moving. So here's another question. I'll give you 30 seconds. Okay, which layer of the wall of the GI tract is largely responsible for motility? And so this is going to be the muscular layer. So the muscularis externa, that thick, smooth muscle layer, which is the third layer out. So we have mucosa, submucosa, muscularis externa, and then serosa. So that thick muscular layer is largely responsible for the motility of the GI. That is the peristalsis and segmentation. Okay, here's another one. All right, which of the following is not a type of receptor that is located within the wall of the GI tract and involved in regulation of GI function? So we described osmoreceptors that detect osmolarity changes, so the presence of fluid, water, solutes. We described chemoreceptors, we described mechanoreceptors. Nociceptors, excuse me, nociceptors are actually pain receptors, and those are not present in the GI tract, and those are not involved in regulation. So nociceptors are, although we did not speak about this term, this is not one of the three that we described. Okay, and these are essentially pain receptors, nociceptors. All right, let's look at another question here. All right, which of the following functions as the stimulus for secretion of CCK or cholecystokinin? So let's go over these. Carbohydrates in the stomach, no, that's not going to stimulate CCK, rather that's going to stimulate gastrin release. Okay, fat or protein digestion products in the stomach, yes, that will stimulate CCK. So fat or protein digestion products as well as distension of the duodenum will stimulate CCK. C is acid in the duodenum, that's going to stimulate secretin release and not CCK. And then D is proteins and protein digestion products in the stomach. That's going to stimulate gastrin release. Okay, so A and D are stimulating gastrin release. B is stimulating CCK. C is stimulating secretin. So the answer here was B. Okay, let's look at a final question here. Okay, which of the following substances inhibits gastric secretion and motility, stimulates bile and pancreatic bicarbonate secretion, and potentiates CCK? So that is secretin, okay? Really straightforward. Remember, secretin, CCK, they both have that S sounding, if you want to use that as a way to remember it. Both of them have similar synergistic relationships, similar responses, and they potentiate each other, okay? Gastrin is kind of the evil twin brother of these two. They have an opposite relationship where they're going to be acting on the stomach, and things that stimulate gastrin inhibit CCK and secretin. Things that inhibit gastrin, stimulate CCK and secretin. Okay, GIP we know is going to block gastric acid secretion, but it's not going to do these other two things, stimulate bile or stimulate bicarbonate fluid or potentiate CCK. Rather, the second function that it will do is stimulate insulin release from the pancreas. And then trypsin is the activated form of one of our pancreatic enzymes that breaks down protein. Okay. All right, so the answer here was secretin. Okay, so that is all I have for you guys in the way of review or revision. Please use the weekend and tomorrow to kind of simulate all this material while you study and prepare for the exam, the second exam. And then reach out if you have questions next week on GI or even renal topics, okay? Next week, we're gonna get into the reproductive system, and then we'll probably reserve that final week for some even more comprehensive review for that second exam, okay? Take care, and I'll see you guys on Monday. Have an awesome weekend.